databases. So that's one of the main activities that I'm involved in. But I was asked to talk to you about fair chemistry today. So I'm going to do a bit of both, actually. I'm going to start with fair chemistry and then move on to a little bit about what we're doing in aggregation and data infrastructures for a national scale. So as I said, this poster is trying to bring together the different areas of fair activity in chemistry, and so all you really need to do here is focus on the colours, if you like. So in the light blue, we have the activities that are largely coming out of the Research Data Alliance, and that's an activity called the Chemistry Research Data IG. IGs are groups within the RDA, and they're looking at some of the more technical aspects of recording process and the likes. And then the large area to the right-hand side of the slide in peach is representing IUPAC. I think the other speakers throughout this workshop have touched on IUPAC activities, and a number of those involved in driving this forward in this workshop today. IUPAC has been involved in setting standards around terminologies and nomenclature, quantities, methodology for decades now. So the infamous colour books have been around for a very long time as references for those kind of things. And these are increasingly turning digital, and we hope to be very core resources for driving interoperability and standards in chemistry. And right at the bottom, there's this thing in green, which I ostensibly head up, which is called the Chemistry Implementation Network, and that is born out of the Go Fair project, which is a European activity. And that is looking at the whole, can we pull everything together at the whole discipline level, and what can be gained by trying to interface to other whole disciplines. So Go Fair is trying to pull together a range of disciplines and see where there's interactions and overlaps. And the circle in the middle is meant to illustrate that these three activities are trying to work together in concert, if you like. There are ways in which they overlap, and in fact I think inevitably they're going to kind of coalesce into one activity, mainly because most of the same people are involved in driving these things. But we're trying to address some of the key fair challenges in chemistry around things like standard representations that cover all of our subject area. How do we normalize normalization processes, if you like, and approaches? Those are kind of findability issues. There are accessibility issues that we're all aware of, whereby much of our data is locked into proprietary systems or PDFs, and data is captured and value added, but these tend to be in localized operations. We do interoperability, but again, that tends to be localized and addressed at solving a particular problem. So, how do we do that across the borders is another challenge. And what we probably also don't have, because of these pockets, localized pockets, is a community that comes together to review digital standards. It's done by committees operating under particular projects or in specific areas. So how do we create more of a culture across our entire community to review standards is a key thing. And then there's issues around reusability that are all kind of arise from these factors that come from the other parts of FAIR, if you like, and trying to balance data producers and consumers so that we can improve science overall and move forward on both sides. So there are a number of workshops and different activities that go on. So I'll get to some slides now. I hope that you can actually read. So the idea, the overarching idea is that we try and create a fair chemistry culture, rather more across the discipline rather than these pockets in isolation. And the idea is, can we feed into a governance structure that is probably run or organized by IUPAC? It's the most obvious organization within our domain. But at the same time as doing that, can we understand where the most serious gaps are, and can we plug them? It's the question. Can we identify the right people and the right means to plug them? And at the same time as bringing together all these standards in some kind of aggregated way. So there's this thing called the CHIN, which, as I said, is probably moving towards coalescing with the Research Data Alliance and the IUPAC activities. But in general, these things are meta organizations, and they act as a way for the community to home in on fair activities. And what we want to try and turn that into more, essentially needs more people, is some kind of advisory system, a way of providing best practice, advocacy, and ways forward, guidance for the community as a whole, if you like. So that's probably all I want to say on CHIN. This is one of the things that we have been trying to get off the ground. So it's essentially a repository of standards, databases, policies across the domain, and it's built on this this fair sharing platform, which means that it integrates with other databases, policies, and standards from other disciplines. So we're slowly but surely getting more and more of our assets, our fair assets, if you like, and fair activities into this collection. And the idea is to build ways on top in which we can provide guidance. So how can we string these things together from the repository and to provide guidance for specific people in our community trying to do particular things? Okay, so this was another picture that was on that poster and has been used a number of times, but zooming in on it, I am trying to give an idea of where the three different fair activities kind of fit within the grand scheme of things. So across the top there is a standard sort of experimental process, if you like, and the mechanics of that are supported by much of the activities of the CRDIG and of the RDA. And that's about understanding samples, the analyses one performs upon them, process data, supplemental information, reactions, that kind of thing. IUPAC standards are, and you heard about this yesterday, I think, are looking at things like structural representation, how one standardizes and handles things like spectra, reactions, identifiers, those kind of things. So these are all the standards that enable or are required to support the process as a whole, and they're where GoFair is looking to get involved and help is the activities that then ensue from that. So if we gather our data correctly, if we describe it correctly and are able to make it available in a digestible way, what are the things that we can then do? And that's where GoFair is trying to make an impact. Okay, I'm going to change gear rather somewhat now, take this opportunity to give some insight into what's currently going on a bit in the UK, or from my perspective, and it does of course build on the FAIR principles and the FAIR chemistry culture that we're trying to grow. So this is a thing called the Physical Sciences Data Infrastructure, and I'll just give you a few slides about what we're trying to do here. So about a year ago, I headed up an exercise which made a pitch to our government funding agency saying that we need to bring our community together. We need proper infrastructure support for data management, data availability, and the exploitation of data. So how do we do all that? So it basically kind of garnered the community, got everyone together, and made a case to the funding agency, and they came back around October, November time and said, we like the idea of this. We think we need it, and we're probably behind other disciplines in other regions of the world in this. So here's some money to go out and explore what that should be. Can you come back with essentially with a set of specifications? So at the moment, we're frantically trying to engage with the whole UK physical sciences community to understand their data needs, how they need to capture and manage data, how they use data, and what kind of fabric infrastructure would enable the support of that. So it's very much in the spirit of this this workshop, if you like. And this is where that I can give some comparators, or where I make a case to our funders that we're kind of behind and need to get into this quickly. Similar initiatives in other countries that you've had represented at this workshop, and many of you will be aware of, are things like the Materials Genome Initiative in the US, NIMS in Japan, the NFDI in Germany, and a number of European infrastructures such as NOMAD, etc., which are all working in the materials space. And we basically don't have anything in the UK, so we need to catch up. And within the UK environment, there's already a lot going on in health and life sciences, medical sciences, and on the other side in environmental sciences, and basically physical sciences is lagging behind somewhat. I think many of you might feel that there's a familiar story in some of your countries, but I think we feel it particularly here in the UK. And so this is the way we're approaching it. We're thinking about the different areas of activity. So we're grouping according to these vertical pillars, if you like, where we have communities and data gathering and data requirements at large centralized facility scale on the left-hand side, going through small and medium-sized facilities as we move to the right, and looking at simulation and computation. So that's one of our key drivers, is can we bridge the divide between the experimental and simulation spaces in our domain. And all the way over on the right-hand side, we're looking at more individuals in their research groups and laboratories. So those are the sort of groupings we have for different kinds of data users, and we're looking at trying to amalgamate all of that on a data level through infrastructure and architectures that enable working across these divides. Largely these are sort of silos or areas within which people work, and it's quite difficult to traverse them. So data infrastructures to enable that, but also we're looking at skills and centers for supporting humans, if you like, that would enable all of this as well.
Sorry, Simon, I can give you 2 more minutes if that's okay.
Okay, yep, that's great. So these are the kind of things that we're trying to do. They're fairly obvious, high-level things that most of you will be aware of. I think the one thing I want to emphasize yet again is bringing together the outputs and inputs, if you like, of simulation and experimentation. These are the kind of communities that we're currently engaging with. It's a similar slide as I showed before, so I won't really dwell on it. But I did feel that there was talk about things like electronic lab notebooks in this workshop previously. So these are the kind of tools and data integration tools that we're looking to use to support across the board, as well as repositories, access to compute facilities, that kind of thing. This is a very quick cache of the kind of architecture we're looking at. Storage and scalable databases stuff at the bottom, an interface layer in the middle, and then the ability to use the data either by machines for simulations or for other reasons nearer the top. And then we're driving all this with some case studies. So that's these last couple of slides is what I want to leave you with. These are some practical applications that we're basically playing around with as demonstrators, test cases, from which we're trying to pull out recommendations and specifications for this infrastructure. So I will just fly through them. The first one is bringing together data around catalysis. We've got a hub for catalysis based at a central facility, generates data from lots of different experimental facilities that we're trying to pull together to feed into simulation. Simulation-driven materials discovery is all about crystal structure prediction and how we can explore landscapes of crystal structures and identify areas of interest and feed those into autonomous robots that are actually synthesizing materials in those areas of interest. Then the materials physics one's about magnetism and magnetic materials, and doing natural language processing of the literature to develop databases to identify areas of interest, go away, do the experiments, and then augment our data sources with experimental data to refine that. We're looking at spectroscopy data infrastructure, just an example of the kind of repository systems that might be needed for experimental data. What tools and requirements are needed to get data in to such things and support people to do these experiments, and how is data in this these kind of repositories going to be used. There's a bit about how we add metadata for curation instrument-based facilities. So what shim tools can we put in the interface between instrument software and data sources to better augment those. We're looking at processing, recording, and electronic or digital research notebook systems, ways of recording, everything from Google Docs through Jupyter notebooks to real structured lab notebooks. There's a case study on trust and sharing, the notion of data exchanges and developing chains of trusts or data trusts themselves, so that we can exchange data more readily and know what it is that we're giving and receiving. And finally, Ian Bruno, who I think spoke yesterday, is looking into the role of structure as a key piece of metadata, adhesive glue, the thing that ties together data in the physical sciences, and looking at our requirements there. So that's where I'm going to stop. Thank you, Matthew. Sorry.